Have you ever looked up at a giant commercial airliner, a metal bird weighing hundreds of tons, and truly wondered, how does that stay up there? It defies logic. A rock falls, a feather floats, but a massive Boeing 747 glides effortlessly through the clouds. It's not magic. It's the beautiful, intricate dance of aerodynamics, governed by four fundamental forces. Get ready to have the mystery of flight revealed, from the ground up. The four forces of flight. For an airplane to fly, it must perfectly manage a push and pull from four competing forces. Visualize an invisible cross acting on the aircraft. Lift is the upward force generated by the wings, and it must overcome the downward pull of weight, gravity, on the plane's total mass. Meanwhile, thrust is the forward force created by the engines, and it must overcome the opposing force of drag, air resistance, that tries to slow the plane down. For steady level flight, these opposing pairs must be perfectly balanced. Lift equals weight, and thrust equals drag. Generating lift. The wing's secret. The key to flight is generating lift, and that's the job of the wing, specifically its cross-sectional shape, called an airfoil. Most wings are curved on top and relatively flatter on the bottom. As the plane speeds up, air hits the leading edge and splits. The air flowing over the curved top has to travel a greater distance in the same amount of time as the air flowing underneath, causing it to speed up. According to Bernoulli's principle, faster-moving air has lower pressure. This difference creates a region of low pressure above the wing and relatively higher pressure below the wing. This pressure difference is what creates the upward force we call lift. Lift is also generated by the wing being angled slightly into the oncoming airflow, called the angle of attack. Imagine holding your hand out of a car window and tilting it up. The air pushes your hand up. The wing does this, pushing air downward. And by Newton's third law, for every action, there is an equal and opposite reaction. The air pushes the wing upward. This is why even planes with symmetrical wings, like acrobatic planes, can fly inverted. They simply use a high angle of attack to push the air in the opposite direction. Thrust and control. To move forward and generate the necessary airflow over the wings, we need thrust. Modern airliners use powerful jet engines that suck in air, compress it, mix it with fuel, ignite it for massive expansion, and blast the hot gas out the back. This reaction drives the plane forward, again thanks to Newton's third law. The streamlined shape of the aircraft minimizes drag, but pilots use surfaces on the wings and tail to manage flight. Ailerons on the wings control the plane's roll, tilting it side to side. Elevators on the horizontal tail control pitch, tilting the nose up or down. The rudder on the vertical tail controls yaw, swiveling the nose left or right. For a specific example, consider landing. The plane needs high lift at low speed to touch down gently. To achieve this, pilots deploy flaps, which are extensions on the back of the wings. These flaps temporarily increase the wing's surface area and curvature, generating maximum lift while also increasing drag to slow the aircraft safely. And there you have it, the magnificent physics that lifts a heavy machine into the sky, a mastery of pressure, motion, and balance. Would you like to explore one of these concepts, like Bernoulli's principle or Newton's laws, in more detail?